Hey everyone, welcome back. In this lesson, we're going to start talking about some of the same stuff that we were discussing in the last video, which was horizontal, vertical, and diagonal lines that were pointed in the opposite direction. So if you remember, before the last video, basically if we drew our Cartesian plane kind of like this, all of our lines were angled so that no matter where they passed through one or both of the axes, and no matter how steep the slope was, they were always sort of pointed from the bottom left towards the top right, right? So we always had a positive slope. So our slope, I'll just write positive slope. So these lines always had a positive slope, and all we did was change the specific value of that slope, but we didn't change anything else about it to the point where the line was perfectly flat, perfectly vertical, or pointing that way. So in the last video, hopefully the discussion topic was reasonably clear. It is a little bit difficult sometimes to wrap your head around the idea of particularly an undefined slope, so basically a vertical line. But so basically what we've got is we've got these four different types of lines that we could encounter. We've got the ones with a positive slope, which is the ones we've been working with. We've got ones with an undefined slope. So that would be vertical lines. We've also got, so if this, just to label the axes, just so that we can sort of tell that there's some sort of difference between the lines that I'm drawing and the axes that we've got. Don't worry about like actually putting any tick marks or anything like that. This is just so you can sort of see that those ones with the ticks are the axes, and then the things I'm drawing on top of them are the actual lines. So we've dealt with positive slopes. Last time out we talked a little bit about undefined slopes, and we talked about lines, let me see if I can, let's put it right here. Perfectly flat lines, so with a slope of 0. And so these ones are horizontal. Squeeze that in there. Perfect. So we've got, we've talked about positive slopes, 0 slope, so a perfectly horizontal line, undefined slope, which is a perfectly vertical line, and now we're beginning our discussion on working with negative slopes. So that would be if we had a line that looks something like this, let's say. So something like that. So it's a diagonal line, but it's pointed in the opposite direction. That is with a negative slope. So instead of being pointed from the bottom left to the top right, it's from the top left to the bottom right of the diagram. So this is basically, these are the four different types. So we've got our positive slopes here. We've got, well, you don't have to number them in any particular order. We've got 0 slopes there, negative slopes here, and undefined slopes there. And it's not that they're any easier or harder to deal with based on how I've numbered them, but these are the four different types of slopes that we have seen with lines. And we've mostly worked with positive slopes, but what I'm thinking we'll do today is, time permitting, we'll do, I think, 2 examples. First, we'll do one where I give you the equation of a line that has a negative slope, and we'll try to graph it. And then what we'll do is we'll graph a line and see if we can get the equation for it where that line is built to have a negative slope, just so that we can see how the process is similar, but also how the process can be a little bit different. So without further ado, you don't have to have all of this written down. I don't know if I mentioned that at the beginning. My apologies if I did not. Last night was a very busy night in terms of studying, so I'm running on very little sleep. Yeah, so hopefully I don't make any mistakes when we're doing our calculations, because that would not be very good. But yeah, let's get right into the examples. I'm trying to slot this lesson in between going to 2 lectures on campus. So I went to a lecture this morning, I've come back, we are now recording, and then as soon as this one's over, I'm going to get some food and go back onto campus. So, yeah, so let's make sure we get these two examples in, because it would be a little bit poor in terms of timing on my part um, if we did only one example now and then the other example has to wait until after the weekend, which might be how it ends up working out anyway, but we'll see. So let's call this practice working with negative slopes. Practice working with negative slopes. Great. All right, so what I'm going to do is just the same way we always did for our questions where we start off with the equation, is we're going to draw in our Cartesian plane, label the axes, x and y, and we'll put in a few tick marks. It doesn't have to be anything we don't have to densely fill it with numbers. We'll just put out a few. Let's go up to 4, let's say, on that side, and we'll go up to 4 if we can make it on this side as well. That looks about right, although this looks a bit, the spacing is a bit off on this side. Let's go for there and there, something like that, perhaps. Looks reasonable to me. All right, and then we go down. Let's see if we can get 4 in there, and we'll try and get 4 in up here as well. Brilliant. Okay, so let's label those. Let's label those axes with these numbers as well. And then we will get started, and I'll give you guys an equation, and we will work together to graph it. So I know I gave you an assignment just a few days ago about graphing and going from the equation to the actual plot. But what I'm thinking of doing is, instead of doing a whole bunch of extra practice on this, it might be more beneficial to you guys to actually get an opportunity to do it yourselves. So what I'm thinking right now is that so I'm recording this on a Thursday, so I'm thinking instead of preparing another video lesson for your next class, I will give you guys another assignment to work on, and that's just for your own benefit, for your own practice, so that you can kind of gain some familiarity with doing these things on your own, because once we get through this stuff, I have an idea for something that we could do after that, which is a bit more complicated and definitely a bit more involved in terms of the calculations that we have to do. But regardless of whether or not we do that, this is stuff that you should really, really know for the test, because it's not going to get any easier than graphing these lines and figuring out the equations based on the graph. So don't worry too much about a test just yet, because I do want to take this unit and the next one reasonably slowly. Yeah, just something to keep in the back of your mind. I will try and get an assignment out tomorrow or the day after that, so that you guys have something to work on in the not so distant future. Alrighty, let's see if we can graph, and I think we'll use the shortcut just because I'm feeling a little lazy today due to the lack of sleep. But let's graph the function y equals -1/2 plus 2. Alright, so this is going to be the function that we are graphing. So you can write that down on the side of your page. And so the first thing we need to identify is what is our slope and what is our y-intercept. These are the two questions we need to ask ourselves. So I'll just put those right down here, slope and y-intercept. All right, and I may end up going slightly faster through this example just so that to make sure that we have time for the next one, but I'm not going to go too fast because we are using the shortcut after all. So for our y-intercept, I've already made a mistake. It's not -1/2 plus 2, it's -1/2 x plus 2. That would be the fault of my lack of sleep. Yeah, sorry about that. So there's our equation of our line. So we've got y equals negative 1/2 x plus 2. Don't forget that x in there, because otherwise we're not, we wouldn't have any, we wouldn't have had any slope whatsoever. It would have been a zero slope if it was, I mean, maybe it's a good thing that I made that little bit of a mistake. So now we can see if I had something like this, there is no term that has an x in it, right? So there's nothing being multiplied by x. So if you look at your original equation of a line, mx plus b, there's nothing in this equation that really fits the bill of that m spot right there. So that means that this whole thing, once you do the addition of negative 1/2 plus 2, that all fits into just that little b over there. So I could trip you up that way as well on a test. I'm going to try not to be that mean, because this one, it was just an honest mistake that I left out the x. But that's just, I mean, I guess the opportunity presented itself to discuss what happens when you've got no x's whatsoever in the equation. So if you've got no x's in the equation, then that means that you've got no number that can really fit that that description of being the slope. And if you've got no x's whatsoever, that means you're in your equation of your line. In this, if you've got no x's whatsoever, that means m has to be 0, because that means this entire thing has to disappear. So if you happen to see y equals just a number or just a series of numbers, it's going to be a perfectly flat line, and all that changes is it a flat line here, or is it a flat line up here or down there? But it's going to be a flat line regardless if you don't have any x's in there, and it's just y equals some number. But anyway, back to the problem. So here we need our y-intercept. So if I keep erasing the equation of a line, but maybe it would be useful to have it here. So we've got y equals mx plus b. So here our y-intercept is going to be the number that's not attached to the x. So it's definitely not going to be this 1/2 over here, because that's being multiplied by that x over there. So our y-intercept cannot be this negative 1/2. So our y-intercept is going to be that positive 2 sitting over there at the end. And if you want, you could write it in as a little positive 2, but you don't have to carry the plus sign. You just have to carry a minus sign. But if it helps you remember to carry the sign with it, then feel free to write in a plus 2 as well. And so then our slope, with our y-intercept taken care of, our slope has to be this number that's being multiplied by x. So in this case, that's going to be negative 1/2 is going to be our slope. And so that's just come from this right here being multiplied by x. And so that means that it's going to be our slope in this particular problem, because that's the way the equation of the line is set up. So now let's go and graph this, but we can't graph it quite just yet, because we need to figure out our first point. So we have a clue for how to get to our first point, and that comes from the y-intercept, but remember that basically for your y-intercept, this number, so the value of your y-intercept tells you where on the y-axis you're plotting your first point. So you don't have to move left or right away from the origin to plot your first point, as long as you're using the y-intercept for that point. So if you're using your y-intercept, you start at the origin and you just go up or down however many units it tells you, and make sure you don't go left or right at all. So as long as you stay on the thick black line here, then you should be able to find that value. So in this case it's plus 2, so right here, and we can put a dot right there, and there's our first point for this graph. Alright, fantastic. So now what we can do is we will use we'll use the less mathematical version of our slope equation. So we had slope is equal to rise over run, which in this case is equal to negative 1/2. Let me separate that a little bit so you can tell there's a minus sign. So what this is telling us is that, let's say our the way I like to treat a negative slope is I always pretend the run is positive. So basically I always treat the denominator to be positive. So if I've got a fraction with a negative number in here, I always just move the negative sign into that numerator, so that now the denominator is definitely positive and that numerator is definitely negative, because that's going to help me out in figuring out which direction I need to go in from my starting point over up here. So if we look at our rise over run of -1/2 here, what this is telling us is that we need to go 1 unit in the vertical direction, but because it's a minus sign here, instead of moving up like we normally would, we're going to move down. So our rise is going to be 1 unit down because of the minus sign there. And then our run, this 2 down here is positive, so the run is still going to be to the right. But our run is 2, so that means that for every unit we move down 1, we go 2 units to the right. Okay, hopefully that's making sense. So if we go ahead and do that, so we go down 1 unit, and then we go over once, over twice, and we plot our point right about here. Something like that. And what that lets us do then is we could go ahead and plot another one, or we could try and simply connect those dots right now and graph the line. So once again, just remember, if you're short on time on the test and you want to just quickly mark off the 2 dots and then draw the line, 2 dots is all you need. You don't need anything more than that in order to graph a linear function. So you don't need 5 or 6 points all lined up and really close to each other. You could have 2 dots on opposite ends of the graph and it'll still work out for you. So let's go ahead and, just for the sake of practice working with negative slopes, we'll go through this process one more time. So if we do that, then with our rise of -1, that means from our new point over here, we have to go down 1 unit, down because of the minus sign, and then we're only going 1 unit because of the 1, and then we have to go 2 units over to the right again. Remember, it's always to the right if you're keeping your run positive. If you prefer to do it that your rise is always positive and your run is always negative, so basically if you treat that minus sign like it's always in the denominator, go right ahead. That's perfectly valid and that's perfectly fine to do. Like, it'll still get you the right answer provided you do it right. It's just been my preference to make the rise be the thing that changes. So it's always am I moving up or am I moving down, but there's never any question about whether or not I'm moving to the right. So I always move to the right, and the negative sign tells me if I'm moving up or if I'm moving down. So if we repeat the process, we've got a -1 in the numerator, so that means our rise is -1, so we go down 1 unit, and then our run is 2, so we go over 2 units. 1, 2, put a dot right there, and we can see definitely that these dots are lining up, so let's try and connect those. If you've got a ruler, please use it. I'm going to have to do this. I can't really see where I'm going with this, but I think something like that should do. That line might be slightly curved, but I think you get a general idea of what we're trying to draw here. So there would be an example of a line with a slope of -1/2 and a y-intercept of +2. So there's our y-intercept of +2. The slope is negative because it's moving in that direction now. We've mostly drawn lines going this way. And it's -1/2 because of that specific angle, that it's down 1 unit over 2. Down 1 unit over 2. If it was down 1 unit over 3, our slope would be -1/3. If it was down 1 unit over 1, our slope would be -1. So like -1 over 1. So yeah, so that's all that we really have to worry about there. And hopefully there's not too much else that's really new about this type of problem, because we've done these graphing questions before. It's just a matter of how comfortable are we with those pesky minus signs, because I know minus signs tend to stress a lot of people out, and then they make mistakes, and then it just kind of goes downhill from there. So what I'm going to do now is I'll get rid of this equation over here, and I'm going to do my best to just erase the line that we drew, so that I can sort of preserve the rest of the graph. You guys, if you can't really do that, then down below the first graph, let's draw in a second Cartesian plane. Ordinarily, I think you guys know that I wouldn't mind drawing out the second Cartesian plane from scratch and just erasing everything that we've got here. But in the interest of getting through the second example without having to rush, I'm going to do it this way, just for today, just because I've got a class to get to that I really shouldn't be missing. But other than that, I would have had no problem with erasing this Cartesian plane and just drawing the grid all over again. So there we go. In the time it's taking me to erase the line, that's giving you guys an opportunity to draw your own new Cartesian plane. So I think I got rid of all the dots, yes. Alright, fantastic. So once you guys have that drawn out, hopefully it doesn't take too much longer, we are going to plot the following points. So points to plot. So for this one, we will plot, let's see. All right, let's keep this relatively straightforward, and then perhaps we'll make it slightly more difficult on the assignment and do some more practice questions next week on this stuff. But so points to plot, well, let's keep it reasonably simple. I'll let you have a point that lies right on the y-axis, so we don't have to do too much work to find the intercept. So we've got, let's say we have a point at 0, 1, and we'll have a point at, let's say, 1, -1. Those will be the only 2 points that we plot, and then we will use those 2 points to find the equation of the line. And it'll actually be, hopefully, just as easy as it was the last time we did a question like this. But so let's go ahead and plot those points. Remember, it's x-coordinate first, and then the y-coordinate. So if we go ahead and plot that, hang on, I got something in my pocket getting in the way here. Okay, perfect. So if we plot that first point, we've got 0, 1. So that's having a 0 as that first coordinate tells us that we're right on the y-axis. So that means I don't need to move left or right. I only need to move up or down, and I only need to move up 1 unit because of this 1 over here. So that means that my first point is going to be right there. So 0 in x, so I don't move left or right, and then I move up once in the y direction, and that's about it. And for our second point, we will start with our x-coordinate, so we move over 1 unit in the positive x direction, so that's to the right, and then we move down 1 unit in the y direction, so in the negative y direction, because of that minus sign, so we move down, and we put our dot right about there. And so now we'll connect those dots. If you feel you need a third point just to be able to make your line straight, I'll give you another one. 2, -3 should also lie on this line. So if we've got 2, -3, that should go right about down here. And that should line up reasonably well. And let's see if we can join those up. Something like that. Alright, so there's our line. So we've just constructed the graph of the line that we now want to determine the equation of. So I'm going to erase these points to plot, and we're going to try and figure out the equation. Alright, perfect. So, first things first, we know our standard equation of a line is written in the form y equals mx plus b. Now, excuse me. Now for our y-intercept, that should be fairly easy because I've given us a point that lies directly on the y-axis that we can work with in this particular problem. So for the y-intercept, if you can find the point that's on the y-axis and then just read off the number for where it crosses the y-axis, that is your y-intercept. So in this case, your y-intercept would be right where the line passes through the y-axis, which in this case is 1. So that's right at the point 0, 1. So your y-intercept is going to be 1. 0 is just telling us we didn't move in x, so that tells us that we stayed on the y-axis, and then we moved up 1 unit, so there's our y-intercept. Now for our slope, we know our slope is equal to rise over run. Right? But we can also write that the other way, the more mathematical way, which is y2 minus y1 over x2 minus x1. All right, now let's just focus on those first 2 points. I'm going to get rid of our title so that I got some space to put those points in. So point number 1 is going to be this first one up here. So this was the point 0, 1, and then this one over here was the point 1, negative 1. So the first point was the point 0, 1, and then point number 2 is the point 1, negative 1. All right, so there are 2 points, and we're going to use this equation down here, this y2 minus y1 over x2 minus x1, to determine our slope. So if we go ahead and do that, look, basically our x1 and y1 are just the x and y coordinates of point number 1. So this 0 in here is, I don't know if you can see that arrow very well, this 0 in here is our x1 coordinate, and this 1 in here is our y1 coordinate. Alright? And then similarly down here, this 1 is our x2, and this negative 1 is our y2. You don't have to draw in those arrows to label those points. I'm just trying to do it to show you what's going on. So remember, x coordinates are on the left, y coordinates are on the right, and then just the numbers just match the points. So we just named them point 1 and point 2, or point A and point B, in which case you'd have like yb minus ya and xb minus xa. But aside from that, nothing overly complicated, hopefully. So in the next line, let's just write out y2 minus y1. So y2 is this negative 1 right here. So let's throw that in. So we know we're going to have a fraction, so we'll put that big line in. y2 is negative 1. Great. So that's the y coordinate of this second point down here. So that's the negative 1. Minus y1. And y1 is positive 1. So we've got a positive 1 right there. So that's the y value of this point right here, which is positive 1. So we've got negative 1 minus 1 in our numerator. Now let's deal with the denominator. We'll put in x2 and x1. So x2 is 1. So that's the x coordinate, so how far away from the origin we've gone in the x direction. Basically how far away from the y-axis we are. So that's our x coordinate is positive 1 for that second point. So we've got a 1 down here. We put in our minus sign. And then x1 is the x coordinate of point number 1, which in this case is 0, because for point number 1 we didn't move left or right at all. So we get a 0 in there. Alright, so now we just got 1s and 0s. Pretty easy to do the calculation here. So if we do negative 1 minus 1, that'll give us negative 2. And then in the denominator, we got 1 minus 0. We haven't really subtracted anything, so that means it's negative 2 over 1. The 1 minus 0 is going to give us 1 in the denominator, so that just stays there. But if you've got a denominator of 1, that's just the same thing as writing a whole number, which is whatever the numerator is. So negative 2 over 1 is the same thing as just good old-fashioned negative 2. So now we will plug in all this information. So we've got our y-intercept is equal to 1, and we've got our slope is equal to negative 2. So here's an example of a negative slope finally. And I'll just use the space up over here where we can plug in that information. So we've got y equals mx plus b. M is our slope, which we just calculated to be negative 2. So instead of mx plus b, I'm going to put in a negative 2 in place of the m. Then we still keep the x like we always do. And then plus b. Our y-intercept is a positive number this time because we moved up, and it happens to be positive 1. So we get that y is equal to negative 2x plus 1. And that right up there would be the equation of this line. So we've got an equation for this line right here would be y equals negative 2x plus 1. So hopefully you can see from this example and the one before it that it's even when you've got a negative slope, it's still a really, really similar process. It's basically the same process as what we had before. We've just got a few extra minus signs kicking about in some of the fractions and stuff, which makes it a little bit easier to make mistakes, but the idea is the same for all of these questions. So depending on whether you start with the equation and have to find the graph, or start with the graph and have to find the equation, the idea is the same regardless of whether or not you have like a positive slope or a negative slope or a zero slope. We're going to try and steer clear of undefined slopes, so I'm not going to just give you like a vertical line and ask you to describe that for me. We won't worry about that too much, but we'll be mostly dealing with positive and negative slopes because they're a little bit more complicated than zero slopes, which are a little bit too easy. But it offers a bit of a healthy challenge. So hopefully this is making sense. This video is a smidge shorter than the last one, but the last one being in 2 parts and all, it came out to something like 43 or 44 minutes in total. So I figured we'll let you guys off with a slightly shorter than usual one. 30 minutes was always sort of my target at the beginning of the year, and then that sort of got longer and longer, and now I tend to target more like 35 minutes, but we're only at 32 today, so we will call it a day here, and I will see you all in the next video. Have a good one.